Right, so I know I've made a big hype about this lesson, but go ahead and label page 53 with number 23, verifying identities. And before we get started, I'm just going to show you out of the book kind of what we're doing. So what we're going to be doing is using the fundamental identities. I have taught you all of these at some point. Okay, so we learned about reciprocal and quotient identities. I believe that was skill 7. And then we learned about the Pythagorean identities in skill 8. And we talked about the even and odd identities. I can't remember the skill number. But basically, all of these should be familiar to you. And I kept telling you, you want to try to use the identities because the more you use them, the more you'll remember them for when we get to this lesson. And now it's here. So I'm just going to really quickly show you in the book example what it is that verifying identities means. Okay, so here I'm on page 558. It says to verify an identity, we show that one side of the identity can be simplified so that it is identical to the other side. For example, in geometry, you should have done something called an algebraic proof. And say you had 2 times the quantity x plus 3. Well, we know that will, let's change it, and let's add a little bit more. Okay, so let's make it this. Hopefully you can even see that. 2 times x plus 3 plus 5. Now, at the end, this is what it's going to equal. 2x plus 11. But say I ask you to prove to me step by step how you went from here to here. Well, you would say, okay, well, you start with what you have, and then you distribute. And so that would be your reasoning, and you'd say you have 2x plus 6 plus 5. And then you would simplify, you would combine like terms and get 2x plus 11. And that would be your proof that these two things are equal. Basically, we took one side and changed it, manipulated it so that it was identical to the other side. That's what verifying identities is. So look at this first example. We've got secant x times cotangent x equals cosecant x. So you need to verify for me, how is this so? Step by step, and tell me the steps you used. So here's the answer. So we start with one side. They chose secant x times cotangent x. So that means by the end, they want to get cosecant x as their answer. They're going to simplify this into something that looks exactly like this. So their first step, you can see they say apply a reciprocal identity and a quotient identity. So they change secant and they change cotangent. Then here you can see that they simplified. They divided both the numerator and denominator by cosine x, which was common, which equals 1 over sine x. And then they applied the reciprocal identity again and got cosecant x. So hopefully you can kind of see the logical flow. All they did was manipulate. We learned that word in Algebra 2. They just changed the way it looks, but not the value. And notice all these equal signs all lined up. So in the end, we can say what we started with is equal to this, and therefore we have verified the identity. So that's just an example of what this looks like. So now I want to go and first of all give you some strategies, and then I'll show you my notation that I'm going to require you to do for your identities. Now every teacher may be a little bit different, but there's going to be some commonalities between mine and what you might see in college. But first, let's talk about strategies. You can see there's a list here, and there's many, many more strategies. There's no identity that can be solved the exact same way. But there are some guidelines. So first, work with each side independently. This is important. The way they write these problems, they look like they're an equation, but they're not. You're verifying an identity. You want to say, prove to me that one side is equal to the other. So you can't be changing both sides at the same time. Okay, we can't do that. And I'll explain more about why later. But for right now, just know that you can only work with one side at a time. Most of the time, you want to start with the complicated side until it looks like the other side. It's a lot easier to boil something down than create something out of nothing. The second guideline, analyze the identity and look for opportunities to apply the fundamental identities, the ones that you've learned. So we're just going to be like tinkering, like kind of like a Rubik's Cube. These are like puzzles, and you're just going to tinker. What identities can I use? Sometimes you'll go a route, won't work. Right? Number 3, rewrite the more complicated side in terms of sine and cosine. That's going to be like our default. If we can't think of anything else, try writing them in terms of sine and cosine, and maybe some things will cancel and work out. If fractions appear, then find the least common denominator and add fractions. So if you've got fractions going on, maybe you can combine them somehow and some things can cancel that way. Number 5, sometimes it's necessary to break fractions apart. So sometimes we want to combine fractions, sometimes we want to break them apart so that we maybe we have one chunk, but we want to turn it into 2 chunks. Then maybe we can break it apart using fractions. Number 6, don't be afraid to stop and start over again if you're not getting anywhere. Sometimes you'll tinker, and you'll tinker for a long time and it won't work. Forget it, start over. Okay, so those are our strategies. In the next video, we're going to talk about notation and tackle our own identity.